Hello guys, I go by my own self to as you all know. Alright, so taking after from the previous class. So we've made a lot of definitions and illustrations. So today we are going to be applying those definitions to the listed questions here. So we have 4 questions here and we want to destroy everything. We want to solve it all. So look at this first question. We are told that we asked that what is the cardinality of the set A into the curly bracket x such that 3 less than x less than equals to 15. This symbol is such that it's 2 symbols we get for such that. In mathematics, whenever you see a symbol like this, it's called such that. Or whenever you see this, it is also called such that. Whenever you see something like this, it is called there exists. So whenever you see something like this, it is called for all. We call this one for all, or you say for every. So instead of you writing it in word, you can just be using all these symbols to abbreviate those terminologies. So and whenever you have something like this, we also have another one. This is row. It is called row, and so many symbols like that. So please familiarize yourself with those symbols. So x such that p is less than x less than equal to 15. So let's solve this first question. Solution. So solution to question 1. Alright, so we are given that a is equals to into curly bracket x such that 3 is less than x less than equals to what? 15. So before you be able to solve this question, because they said you what is the cardinality of this set A, and I told you in the last class, imagine you were told to find the cardinality of set x. How do you represent the word cardinality? It is you just put a small letter x at the back of behind the bracket. So this is cardinality of x. So now we are told to find cardinality of A. So we need to find cardinality of A. This is the representation for the cardinality of A. It's so simple saying that. It means cardinality means the number of elements present in a given set or any set. So you can be given any set, or you are told to find any set, and you are told to also find the cardinality. So the number of elements, and I said element is the member of a set, so the number of elements present in any given set is what we call cardinality of the set. Just count it. So before we can be able to count the number of elements, we have to interpret this. So we have that A, while interpreting this one, we have that A equals to, look at this, forget about this, it's just a true set. So let your focus be on these 2 guys, this from this guy to this guy, these 2 guys, these 2 numbers. So you have to bring it, for you to understand the interpretation, I'll advise you that you bring it 2 by 2. You bring it 2 by 2. So I'm going to bring out this guy here. I'll relate it with x. I'm going to bring out this guy. So bringing out this guy, 3 less than x. So 3 less than x is also the same thing as saying x greater than 3. Do you agree with me? So if I say 3 less than x, it means that x is greater than 3. So what is that value counting? What is that value count that is greater than 3? So you notice that it is 4. You know, after 3 it is 4. So that number that is greater than 3 is 4. Like if you are counting your value. So that which means that this one here determines what we are going to start with. Why this one here? I'm getting there, but this one here determines what we are going to start with. That's we are starting with 4. Alright, we are done with this guy. So now let's come here. You can see what I'm doing. Initially, I picked these 2 guys. Then after I matched them up to get my starting point, then I left them over. Then I continue with this guy. This is the end point. So they said x less than equals to what? 15. So there's something I want you to know. So whenever you are interpreting a 2 set, so if you see less than equals to or greater than equals to, if I say less than equals to 10, just stop at 10. If I say greater than equals to 10, just stop at 10. And just assume it to be equals to, because they all fall under equals to. Even if you are classifying the word equals to, subdivided into 2, the less than equals to, greater than equals to. So just assume you are talking about equals to. If whenever you see less than equals to or greater than equals to, so just assume it is equals to the root here, which means you are stopping at exactly 15. Even if it is greater than equals to 15, that means you are stopping at exactly 15. It can be any number, so you are stopping at that exact number. The only one that will be having effect is if you have less than. Imagine you have x less than 15. So that one, what's that number that is less than 15? That means you are stopping at 14. If you have x greater than 15, that means you are stopping at 16. But so far that it is less than equals to 15, Even if it's greater than or equals to 15, assume it is equal to, like I said, so just stop at the exact number that is there, which is 15. No stress. So that means from 4 we are stopping at 15. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, then 15. Then 15. So you can get that now. So now we have already interpreted it. No stress. So let's begin to find this one. We are finding cardinality of set A. So I told you that set is represented with a capital letter, while element is with small letter. It's not every time they give you alphabet 4 elements. So our cardinality of A is now, what did I say cardinality is? I say cardinality is the number of elements present in a given set. This is a set. These are the elements of this set, the member of this set. So let's count what we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the cardinality of set A is 12. That's our final answer. It's very simple, very, very simple. And at times your questions can be direct. So it's not every time they will give you in this form. But just get ready. In case of any time you are given questions in this form, you should be able to interpret the true set. So let's get down to the next question. Q2. Let's solve question 2. So they said if A is equals to, they have given the element of the set. We have set A, we have set B. So the element of set A are 1, 3, 4, 5, 10. And the element of set B is 2, 3, 10, 11, 15, 20. So we are told to find A union B. Right. So let's analyze it out. We are given that A is equals to 1, 3, 4, 5, 10. Then we are also given that B, our B is equals to 2, 3, 10, 11, 15, and 20. No stress. Alright, learn how to write the curly bracket. So we want to find A union B. In my previous video, I explained in English and I explained in Yoruba for the sake of those that find it out to interpret English. So A union B. So what is union? Union is just like, okay, we're having this guy here, we're having this guy here. So this is the element for the guy. So this guy, these are the followers of this guy, and this guy as well, these are his followers. So they now this guy and this guy, they are best of friends. They are very best of friends. So maybe an event is going to come up and they need to gather up some stuff. So they now felt like, okay, I have what I have, you also have it, and we are, maybe the event that is coming up, we are meant to donate this particular thing. Maybe event is coming up, we are meant to donate coaster, but one carton of coaster. We are both better friends, but an event is coming up, they said we are meant to donate coaster. You understand? They didn't specialize that, okay, you bring one carton every day. They just say we should donate coaster because we are best of friends. So I have coaster, you have coaster. You get, I can just carry one of my coaster and donate. We are just friends. We are friends. So there's no point carrying, because I have coaster and you also have coaster. We should not carry everything and donate it. So far we just both have same thing in common. Let's just carry one of the coaster and keep them. So what am I saying? That union is when you combine the element of two or more given sets together and arrange them in order without repetition. Combine any elements you can see. This is A. These are the elements of A. These are the elements of B. So what are the elements you can notice in these two sets? The elements you can notice, the observable elements you can notice in these two sets. So those numbers you can notice here, combine them together, then arrange them accordingly in numbering form. If it is alphabetic that is inside, arrange them according in alphabetical form. But so far it is number that is the element. Pick what you can notice there. Even if it is common, don't repeat. If you have something here and you observe that the same thing is still here, just pick one of it, don't repeat. So now, what I can notice in these two sets, I can notice that this one has 1. It does not have, it doesn't matter, because we are just trying to list out what you can notice here. 1, we have 2. In these two sets, we assume them to be one family. So whatever you can notice in 2 of them, we list them out without repetition. We have 3. You can see that there's also 3 here, but don't repeat. So far we have already picked one of here, so it is still, they are still one family. Do you understand? So we have 5. Okay, no, we have 4. So whatever I have is also for you. So list me down. That's the meaning. I have 4, you don't have 4. So whatever I have is also for you. So list me down. So I have 5, you don't have 5, we are still together. List me down. So I have 5. So I have what again? We don't both of them don't have 6. So what so we have 10. I have 10, you have 10. Let's just put one. We are still the same family. I have what? 15. I have 20. No, I have 11. Sorry, there's 11 here accordingly. 11, 15, and 20. So you can see all these elements, we can notice everything inside these two sets. All these elements we listed and we can notice it. Do you notice that some elements are appearing here and also appearing here? So regardless of that, we did not repeat anything. So elements that you can observe in the given set can be 3 sets too. Even if there are 3 sets, anything you can notice in the 3 sets, you list them out without repetition, even if they are occurring more than 1 times, 2 times in both sides. So is that cleared? So that's very simple, very easy. So this is union of a set. All right. The next one we are going to be doing that. Okay, number 3. Given that A is this, B is this, C is this. Let's solve this problem. No stress. Question theory. So question 3, they gave us that A is equals to 1, 5, 7, curly bracket. B equals to 3, 9, 15, and 21. Okay. And C is equals to 11, 13, 17, and 19. No stress. So we want to find A union B. Let's start with A union B. A union B. So we are going to use the idea of this to solve this. A union B. So what can you notice in A union B? Now A and B, what can you notice here all together? Let's list whatever we can notice in this. So we can notice 1. Even if it's not in the both place, what we can notice in these 2 sets. What are the things we can notice in both of them like this? So we can notice 1, we can notice 3, we can notice 5. 5 is present in either of the sets. What else is present in either of the sets? 7 is present in either of the sets. 9 is present. What else is present? 15 and what? 21. So we have joined these 2 sets together without repetition of those numbers occurring multiple times. So anything the value notice nínú àwọn set tó appear nínú àwọn set the value nǹkan tó jẹ́ bá ti rí nínú gbogbo ẹ̀ kọ́ jáde then list ẹ̀ jáde accordingly in numbering form. So list it out accordingly. So that's it. So the next one, they said we should find B union C. So let's find B union C. So this one is a very good one. B union C. Yeah, now let's look at B union C. What can you notice there? Accordingly, arrange accordingly. Theory between this B and C, what can you notice accordingly in these 2 sets? You can notice 3, 9, 11 accordingly, 13, 15. You can see from lowest to the highest. 19 and 21. You can see that. So I think we're done. So A, B, C. So let's get down to the next one. C union A. C union A. It's not a must for you to start from A, so it doesn't matter the arrangement. C union A. So what can we notice between this set and this set? What did they have like in arrangement? What you can see in these 2 sets, A and C. So accordingly, numbering form 1, 5, 7. 1, 5, 7 is lowest here. Then 11, 13, 17, 19. Oof, we're almost done. So now the next one, they said we should find A union B union C. So this one is easy. A union B union C. So before you can find this, you have to find this one inside the bracket, but we've already find this one from the first question. So it means that we want to find this A union B union this C. So what this element here, what this set, the union of the set here have in common with this one? I mean, we are finding the union of this one here with this. You can see we have this one already. These are the elements of this one. So let us union it with this one. So what can we notice from this one and this one? Please try to get me. What can we notice in this and this? That's 1, 3, 5, 1, 3, 5, 7, 9. Arrange it accordingly. 11, 13, 15. You can see I'm not doing it accordingly. 19. Oh no, 17 comes first. Because 17 is also observable there. 19, 20, 21, sorry. So that's the end of the solution. I think it is well explanatory here. So don't get it confused. If you don't get where I'm saying, please replay this video or you rewind it so that you can get it right. Alright, so the last question I'm going to be solving here. I'm going to be solving this question. Thank God we have a complement here. It covers everything we have here, covers everything. Covers the whole of what we have. Coming. Alright, I will clean this. I'm going to clean this. The last question. Okay. I have that if this universal set, you understand, this is the universal set. We are given that the universal set is 1, 2, 3, 4, 5, 6, 10. But let me just write it in full. 7, 8, 9, 10. Alright. So this is what we are having. So A is 1, 3, 5, 7, 9, and B is even number. In fact, it is very easy to know. These are odd number. Imagine they wrote odd number here. They wrote even number here. So let me just glance through that point. You might come across something like that. They gave you inverse set too. Maybe they told you that this one is whole number or natural number less than 11. Whole numbers less than 11. If you are listing whole number less than 11, you start from 1. Okay, so less than 11. What's that number? When that time you start counting your whole number 1, 2, 3, 4, 5, 6. So less than, or they say positive integer. These are positive integers. Integer is either positive or negative number. So 1 minus 1, 2 minus 2, 3 minus 3. So that's what we call integer. So imagine they say either, maybe they mentioned this one, they wrote it inside the word that positive integers less than 11. So positive integer is from 1 and above. So less than 11 is 10. 10 is less than 11. So you will not get to 11. If they say greater than 11, you will cross 11, bridge of 11. You stop at 12. So if they say whole number less than 11, start from 1, stop at 10. So it can come in any form. Question can come in any form. I'm just trying to let you know. So imagine you are giving this listed one. And I said this one is odd number, this one is even number. So if you want to get the element of this one, the element is going to be gotten from the, if you are giving universal set, imagine they wrote odd number here. So if you now to get the numbers that should be here, it's going to be extracted from your universal set that you are given. You must not go beyond the universal set you are given, except if only you are not giving universal set. And even if you are not giving universal set, if they will write odd number here, they can write odd number less than maybe 9. They can write odd number less than 9. They will specify where you have to stop. You get that now, so that's it. So including this one too, you have to extract it from this way. You bring out all the even number that is here. This is what they extracted there. In case you be coming across a question like that. Alright, so what are we looking for? We are looking for complement of A, that's A prime. I explained it last class. But you want to find something like this. So they say you find complement of A. The word complement is gotten from the word natural, literally is gotten from complete. Like something should complete. So what they are trying to say that if you want to find complement of A, they are trying to ask you that what is the element remaining for A to complete the universal set? So simple as that. They say what is complement of A? What is the element that is remaining for this A to complete the universal set? So in another way you can say that what element do you have in the universal set that you cannot, that is not present in the set that you are told to find? A complement. So A complement can be in this form, or they can write it in this form. No panic, don't let it confuse you. It's still the same thing they're asking you. It can be a complement A prime, so they are serving the same purposes for the same function. So what element is remaining for this A to complete the inverter set is what will give us the answer for this. So we have this one listed already. So what is left? We have 2. 2 is remaining. What else is it? 4, 6, 8, and 10. So that's what is remaining for this one to complete the inverter set. That's what we call complement of the set. So let's say B. Okay, what are we looking for? A intersection B. A intersection B. Now, A intersection B. Intersection means elements 2 or more sets have in common. The elements me and this guy have in common. A guy, maybe a guy and a female, a male and a female. So suppose I have a girlfriend standing right before me. So then they said there was an intersection between us. The intersection means what we both have in common. We have eyes in common, nose in common, and many other things in common. Those are the things you are going to list out. So you understand? So very obvious similarities. Now, what do this guy, this A and B, this guy and this guy, what do they have in common? That's what we call intersection. So let's arrange this in order. They have what in common? Do they have 1 in common? No. Do they have 3 in common? No. Do they have 5 in common? They have nothing in common. So what they have in common is an empty set. Their intersection is empty. They have nothing in common. So the intersection between this guy and this guy is an empty set. You understand? Because they don't have anything in common. That's why I'm writing this symbol for empty set. Assuming they have something in common, I'll just write out the numbers inside and I'll bracket it. Do you understand? So, and if you don't want to use this guy to represent your answer, you can use this symbol. This symbol is also the symbol for empty set. You can use this symbol as well. That of the two is perfectly okay. So, and I told you last time that empty set is set that has nothing, no element in the bracket. They have no element. It's a set that has no element. Or you can define it as 2 or more sets that has nothing in common. There has no intersection between them. And in form of Venn diagram, we call it disjoint set. Like no intersection common to them. They are the boundary for the intersection. The absence of the boundary, the intersection boundary, is obvious. So now this is an empty set. So see, an empty set is a null set. That's the other name for it. So A prime union B prime. We want to find A prime union B prime. That's complement of A union complement of B. So we already know what complement of A is, but we don't know what complement of B is. Do you get it? So we need to find complement of B. We already know complement of B, A. So let's just, instead of wasting time, let's just do it direct. A Jesus Christ. A complement is 2, 4, 6, 8, 10. Union. What is B? What is B prime? We need to find this one. So what element is remaining? What element is remaining for B to complete the inverse set is what will give us this B prime. What element is remaining? 1, 3, 5, 7, 9, and 10. Alright, so that's it. So now you can now find the union. You can now find the union. So the union of this and this. So what do they have? What can you notice that both of them, like, how will I explain it? The union of these two sets, all the things you can notice here, overall elements you can notice here, don't repeat. So we have 1, we can notice 1, we can observe 2, we can observe 3, we can observe 4, we can observe 5, we can observe 6, we can observe 7, we can observe 8, we can observe 9, and we can observe. So it's also, this one is ending up giving us the inverse set back. You understand? So alternatively, because this one is already the inverse set, so that's why it's ending up giving us this one. So there's no point writing, you can just leave it like this. So alternatively, if you go back to my previous video where I proved De Morgan's law, you know this one is similar to De Morgan's rule. So when I have A prime union B prime, it's the same thing as saying that A intersection B or carrying prime. the expression for this one is also the same thing as this one. Go back to that video if you don't understand it, the Mogas rule. So if I have, so for instance, what is my A intersection B? My A intersection B is an empty set. So prime of this empty set, what will be the prime of this empty set? So what is remaining for this one to complete the universal set is still this universal set. So either of the case is perfectly okay. So what is remaining for this empty set? Like the bracket, is two symbols we have for empty set. You can use ordinary bracket and you can use this symbol. So what is remaining for this empty bracket to complete the universal set is still this element that will fill it up to complete it. So I believe you understand this video. Thank you for watching. So take your time to study it. You can find some other questions. So any question you find difficult or the one you don't understand, so make sure you drop them in the comment section or check some of these videos. Among these videos, you will see the checking the descriptions. You will see my contact in some of it. Copy it out. Text me on WhatsApp. If you have any question difficulty, send it to me on WhatsApp. And also, I'll send you our WhatsApp group link, which you can join for more benefits that comes from Airline Tutor. God bless you. Stay tuned. Share to your friends across the globe, whether in my institution or other institution. God bless you.